The next section in adding and subtracting will be subtracting two polynomials. In problem number 1, we're subtracting two binomials because they both have two terms. So instead of adding, we're now going to subtract like terms. I'm going to start with the first term in the first binomial, 3a squared, and subtract its like term, which is 2a squared. 3a squares minus 2a squares is 1a squared. Moving on to the next term, positive 1, we're going to subtract its like term, which is 4. 1 minus 4 is negative 3, in which our answer is a squared minus 3. It is already in standard form. Similarly, problem number 2, 5a minus 5a is actually 0. These cancel each other out, in which we're just left with 4 minus 3. Our answer is 1. Lastly, problem number 3, similar to problem number 3 in the first section of adding, we're going to add the first two binomials, get an expression as the answer, and then we are going to subtract the trinomial from our answer. When you're adding 3y squared plus no y squares, we're just left with 3y squared. Negative 8 plus 9 is 1. There's one term that we haven't combined with anything yet, and that's the 5y. Since there are 0 y's in the first binomial, it's almost like saying 0y plus 5y is 5y. We're now going to take this expression and subtract the trinomial y squared plus 6y minus 4. 3y squares minus 1y squared will give us 2y squared. 1 minus negative 4, 1 minus negative 4 will be adding, will give us 5. And 5y minus 6y will be negative 1y. Again, we should always practice writing our answer in standard form, where the exponents are from the greatest to the least. So we're going to just switch these two terms in our answer. So in standard form, the trinomial as our answer will be 2y squared minus y plus 5. Please let me know if you guys have any questions on the lesson, and I'll talk to you soon. Hey guys, today's lesson is on section 8.1, in which the first page is just about polynomials. We have some terms and definitions here in which we are going to answer about the bottom 4 problems. Terms are separated by addition and subtraction signs. So when we look below at problem number 1, how many terms does that polynomial have? It would have 1, 2, 3 terms. Number 2, the polynomial will have 2 terms, one being 2 and the second being negative 3x cubed. Although the negative, it's a subtraction sign, it's also the sign for that next term. So we have 2 terms. Number 3, there are no addition and subtraction signs. The sign out in front, it would be considered a negative sign to make that coefficient negative 20. That would be 1 term. And problem number 4 has 1, 2, 3, 4 terms. Depending on how many terms a polynomial has, it has a special name for. For example, a monomial is a polynomial with 1 term. So as we look down below, problem number 3 is a monomial because there's 1 term. A binomial is a polynomial with 2 terms. Problem number 2 below will be a binomial. A trinomial has 3 terms, in which that would be number 1. That would be considered a trinomial. And a polynomial is just any polynomial with 4 or more terms. They don't have any special names for those. So number 4, it doesn't necessarily have a special name. It's just a polynomial. The next thing we'll talk about is the degree, in which is the highest exponent. So for problem number 1, the highest exponent I see is 2. Therefore, problem number 1 has a degree of 2. Problem number 2, the highest exponent is 3, in which we would say the degree for number 2 is 3. Problem number 3 only has one exponent, which is 5. The degree for that term is 5. And lastly, problem number 4, the highest exponent I see is 3 again, similar to problem number 2. Problem number 2 and 4 both have a degree of 3. Leading coefficient is the coefficient of the term with the highest exponent. So we're now not looking for the exponent, but the coefficient of the term with the highest exponent. For problem number 1, the term with the highest exponent is our middle term, 2x squared. What is the coefficient for that term? It would be 2. Therefore, our leading coefficient for problem number 1 is 2. The term in problem number 2 that has the highest exponent is negative 3x cubed. The coefficient, or the leading coefficient, would be negative 3. Problem number 3 only has one term, therefore the only coefficient and the leading coefficient is negative 20. And lastly, positive x cubed is the highest degree, or the highest exponent, so the leading coefficient is 5. And lastly, we'll talk about standard form. We're going to rearrange the terms so that the degree or exponent of each term is in descending order. What do they mean by that? In problem number 1, the degree for the first term is 0 because it has no exponent. The degree for the second term is 2, and the degree for the first term, if there's a variable all by itself, has a degree of 1. We want to list those terms in order from greatest to least degree. So the first term in standard form would be 2x squared. The next term with the least one less degree than that would be 3x. And our last term in standard form would be 8. When you're writing in standard form, you're still going to have all of the terms present in the polynomial. We're just rearranging them. In problem number 2, the negative 3x cubed should be first in standard form, then the positive 2. Again, although that's a subtraction sign, it's also the sign for that term. Problem number 3 is already in standard form since it's only one term. And problem number 4, similar to problem 1, the first term has a degree of 0. There's no variable, so there's no exponent. The second term has a degree of 1. The third has a degree of 2. And the last has a degree of 3. So let's relist these in order from greatest to least degree. The first term we'll list in standard form is 5x cubed, then negative 4x squared, then the positive 3x, and then our negative 2. That is what standard form of that polynomial will look like. Again, this first page is just some information about what the polynomials look like and specific parts that they have, for example, terms, degree, and leading coefficients. The next page we're going to look at is we're going to start doing operations with these polynomials, the first one being adding and subtracting. So here are our notes on adding and subtracting polynomials. The first section is adding, in which we're going to combine like terms. So what we're going to do is start with the first term in the first binomial, since that has two terms, and we're going to add it to the like term in the second binomial. What would the like term be for the term of 4? It would be 2, since they both don't have a variable. 4 plus 2 would give us 6. Move on to the next term, 2n cubed plus, is there a like term for 2n cubed in the second binomial? Yes, there is. If I have 2n cubes plus 5n cubes all together, we'll have 7n cubed. If the directions ask us to write this in standard form, we know that the 7n cubed would have to be written first because it has the biggest exponent, and then the 6. The purple and blue answer are technically the same thing, however the blue one, and we should always practice writing our answer in standard form. Let's take a look at problem number 2. I'm going to add these two trinomials. Let's combine our like terms, starting with the first term in the first trinomial. What is the like term in the second trinomial? Well, since it has a k to the fourth, like terms have the same exponents, the same variables with the same exponents. So that like term would be negative 3k to the fourth. Combining those will give us negative 7k to the fourth. Moving on to the next term in the first trinomial, we have the number 14, and I'm going to add it to the like term in the second trinomial, which is the negative 8. Positive 14 plus negative 8 is going to get us positive 6. And lastly, 3k squared plus the like term for that would be negative 14k squared will give us negative 11k squared. Let's rearrange our terms real quick to write our answer in standard form, where the negative 7k to the fourth will still be the first term, but the second term should be then the negative 11k squared. Last term would be the positive 6, since it has no exponent or a degree of 0. Problem number 3, we're adding now 3 polynomials together. This first is a trinomial, 3 terms, then a binomial, 2 terms, and another binomial. What I recommend to do is just start with the addition of the first 2 expressions and then add on the third. 2r squared plus, there is no r squared in the second binomial here. Therefore, it's like saying 2r squared plus nothing is 2r squared. R plus negative 3r would be its like term, is negative 2r. And then our 3 plus 4 will give us 7. We're now going to take this trinomial and add it to our last binomial here to get our final answer. 2r squared plus 1r squared is 3r squared. Negative 2r plus no like terms is negative 2r. There's not a term in the second binomial with the r to the first power, so we can't combine the negative 2r with anything. And lastly, we have 7 plus negative 1 is 6.